The ocean is a vast, mysterious, and largely unexplored world. It covers over 70% of our planet, yet we've barely scratched the surface of what lies beneath. There are still secrets hidden from us, under the waves, where sunlight fades and darkness is king. But sometimes the ocean seems to talk to us, with strange, unexplained sounds that travel for thousands of miles, defying all logic and understanding. What do these sounds mean? Where do they come from? And why do they persist, decade after decade, defying our best efforts to understand them? Today we'll take a journey into the world's oceans, exploring these mysterious sounds and the stories they tell. Prepare yourself for the unknown on Fireside Unsolved, Episode 103, 5 Mysterious Sounds from the Ocean. Before we begin trying to decipher these unexplained underwater sounds, we need to take a step back and look at how these sounds are recorded in the deep ocean. The National Oceanic and Atmospheric Administration, also known as the NOAA, operates a vast network of underwater microphones called the Sound Surveillance System. Originally developed during the Cold War to detect Soviet submarines, this network has since been repurposed for scientific research, monitoring everything from marine life to underwater volcanoes and earthquakes. On March 1, 1999, researchers at the NOAA detected a sound using their network of underwater microphones, known as hydrophones. But this was no ordinary sound. It was loud, it was deep, and it lasted over 15 seconds. And it was powerful enough to be picked up by the entire hydrophone network spread across the Pacific Ocean. To put this in perspective, the Pacific Ocean covers over 63 million square miles, larger than all the land masses on Earth combined. For a single sound to be heard across such an immense distance, it had to be something truly extraordinary. The researchers named it Julia. Unlike the sounds of icebergs, underwater earthquakes, or even the calls of marine animals, Julia didn't fit any known acoustic profile. The NOAA quickly classified it as unknown. Several theories have surfaced, ranging from the plausible to the downright bizarre. The most widely accepted theory is that Julia was caused by the grounding of an iceberg. When a massive iceberg scrapes against the ocean floor or collides with another ice mass, it can produce incredibly loud, low-frequency sounds. But there's a catch. While icebergs do produce loud noises, they are usually characterized by a series of short, sharp sounds, not a prolonged noise like Julia. The unique duration and tonal quality of Julia make it an outlier, even among iceberg sounds. Another possible explanation points to underwater volcanic activity. The Pacific Ocean, especially around the Ring of Fire, is a hotbed of volcanic and tectonic activity. Underwater volcanoes, or seamounts, can generate loud, low-frequency noises during eruptions, collapses, or gas releases. And these sounds can also travel long distances. However, there was no seismic data at the time to suggest a volcanic eruption or tectonic event in the region where Julia was recorded. And without that, this theory starts to lose its footing. Now here's where things get really interesting. Some oceanographers and marine biologists have proposed that Julia might have been produced by an unknown sea creature, a massive one that has yet to be discovered. The idea of a giant, undiscovered sea creature might sound like science fiction, but it's not entirely out of the realm of possibility. Remember, it wasn't until the 1970s that the colossal squid, an enormous creature that can grow over 40 feet long, was confirmed to exist. Yet many marine biologists argue that no known sea creature could produce a sound of Julia's magnitude. The mystery of Julia is a reminder that, despite all our scientific advancements and technological achievements, there are still mysteries in this world we have yet to unravel. The whistle was first detected on July 7, 1997, by the same NOAA network of hydrophones that recorded Julia. But this sound was different. One of the more straightforward explanations is that it could be a natural underwater acoustic phenomenon triggered by shifting tectonic plates or volcanic activity beneath the seafloor. When rocks deep under the ocean's surface are stressed, they can sometimes produce high-pitched sounds as they crack, shift, or grind against each other. Unlike the deep rumbling noises typically associated with earthquakes or volcanic eruptions, these sounds can be much shorter and higher in frequency, something like a whistle. This explanation makes sense, especially given the immense pressures and dynamic geological activity taking place under the ocean floor. But there's a problem. The pitch and brevity of the whistle don't quite match the acoustic profiles of known tectonic sounds. And at the time of its detection, there was no significant seismic activity in the area where the whistle was recorded. Another theory suggests that the whistle could be a form of communication from a marine creature. Could the whistle be a call or signal from a species we have yet to discover, or from one so rarely observed that we don't recognize its sounds? While this idea is intriguing, most marine biologists remain skeptical. The frequency of the whistle is exceptionally high for deep-sea creatures, whose sounds typically occupy much lower frequencies to travel long distances through water. Then there's the possibility that the whistle is human-made. It wouldn't be the first time human activity has produced strange, unexplained sounds in the ocean. So where does this leave us? It's a sound that defies easy explanation and continues to baffle those who study it. Some believe it's a clue to a deeper understanding of the ocean's hidden depths. Others think it might point to a natural phenomenon we simply don't understand yet. Whatever the case, the whistle reminds us that our planet's last great frontier still holds its secrets tightly. Upsweep is not a single isolated noise. It's a continuous seasonal sound that has confounded researchers since it was first detected in August 1991. This peculiar sound has been recorded by the Pacific Marine Environmental Laboratory and has sparked years of speculation and study. What makes Upsweep so mysterious is its persistent nature. It isn't just a one-time occurrence. It's been heard seasonally, primarily in the spring and fall, ever since its discovery. The sound originates from a remote area in the southern Pacific Ocean, near the Pacific-Antarctic Ridge, located roughly between New Zealand and South America. Over the years, Upsweep has shown signs of fading, but it hasn't vanished entirely. Is the source of the sound slowly diminishing, or could something else be influencing its strength? The leading theory among scientists is that Upsweep could be linked to underwater volcanic activity near the Pacific-Antarctic Ridge. This theory proposes that the sound is produced by volcanic vents or hydrothermal activity on the ocean floor. As the water temperature fluctuates, it could affect how sound travels through the ocean, making Upsweep more or less detectable depending on the time of year. However, while this theory is plausible, it remains unproven. The fact that Upsweep appears to be fading over time adds an urgency to solve this mystery. Are we on the verge of losing a vital clue about our planet's inner workings? And if the sound were to disappear completely, would we ever uncover its true origin? First captured on May 19, 1997, Slowdown is a unique noise characterized by a gradual decrease in frequency, as if something enormous were slowly grinding to a halt deep within the ocean. This sound lasts for about 7 minutes, and like the others we've discussed so far, was detected by the NOAA's network of underwater hydrophones in the equatorial Pacific Ocean. What sets Slowdown apart is not only its eerie descending pitch, but also the fact that it has been recorded multiple times over the years, often in different locations. Yet no matter where it's heard, it always follows the same slow, steady shift in frequency. The most widely accepted explanation among scientists is that Slowdown could be the result of a massive iceberg dragging or grounding itself along the seafloor. Another theory proposes that Slowdown might be caused by an unknown oceanic or geological event. Perhaps it could be the result of the slow movement of tectonic plates, the collapse of underwater caverns, or another deep-sea process that we have yet to understand. Of course, there is also the more speculative idea that Slowdown could be produced by a massive unknown marine creature. However, no known marine animal is capable of producing a sound like Slowdown for such an extended period, particularly at the low frequency detected. The physiology required for a sea creature to emit this type of noise would be unlike anything we've ever encountered. Finally, let's dive into one of the most unique and emotionally resonant mysteries of the deep sea: the story of the 52 Hertz whale, often referred to as the world's loneliest whale. Unlike the other mysterious ocean sounds we've explored, the 52 Hertz signal is believed to be the call of a living creature. This sound was first detected by the U.S. Navy in 1989 and has since been tracked by the NOAA. What sets the 52 Hertz whale apart is the unusual frequency of its call. Most whales, such as blue whales or fin whales, communicate at much lower frequencies, usually between 10 and 40 Hertz. The 52 Hertz whale, however, calls out at a much higher frequency of 52 Hertz, which doesn't match that of any known whale species. This anomaly has led to numerous theories about the whale's identity and its unique call. One theory suggests that the 52 Hertz whale could be a one-of-a-kind individual with a physical anomaly or mutation affecting its vocal cords, causing it to produce a call at a higher frequency than other whales. This might be due to an abnormality in its vocal anatomy, which alters the way it generates sound, much like how a person with a different voice pitch might stand out in a crowd. Another possibility is that the 52 Hertz whale is a hybrid, perhaps the offspring of two different whale species, such as a blue whale and a fin whale. Hybrids can sometimes exhibit unique characteristics, and in this case, the whale's mixed genetics might have resulted in an unusual call frequency. An even more intriguing theory suggests that the 52 Hertz whale could belong to a completely unknown species. Perhaps the most poignant theory is that the 52 Hertz whale is a social outcast. Since no other whales seem to respond to its unique frequency, it may be calling out in vain, unable to communicate with others of its kind. This has led to the whale being nicknamed the loneliest whale in the world. Imagine a creature traversing the vast expanses of the ocean, singing a song that no one else understands. It's a profoundly moving idea, resonating deeply with human feelings of isolation and the search for connection. Despite its solitary song, the 52 Hertz whale appears to be healthy. Its calls have been detected for over 3 decades, indicating that it has managed to survive and possibly even thrive on its own in the ocean. This longevity provides a glimmer of hope that we might one day learn more about this remarkable creature, perhaps even discovering others like it, or finding a way to communicate with it. These unexplained and mysterious sounds of the deep ocean continue to baffle, intrigue, and inspire us. From Julia and the whistle, to Upsweep, Slowdown, and the poignant calls of the 52 Hertz whale, these mysterious noises are reminders of just how little we know about our oceans. Each sound we've discussed today is like a piece of a puzzle, a clue to the secrets hidden beneath the waves. They call on us to explore further, to listen more closely, and to seek out the unknown with curiosity and wonder. So what can we learn from these oceanic mysteries? Maybe it's that our world is still full of surprises, that there are still frontiers left to explore and mysteries left to solve. And that, in itself, is a beautiful thing. Thank you for joining us on this deep dive into the mysterious sounds of the ocean. If you enjoyed this episode, please be sure to like, subscribe, and share it with your friends. And remember, keep your ears open, keep your curiosity alive, and always be ready to dive into the unknown. Until next time, stay safe out there. We'll see you next time. Fireside.
Thank you for joining us for another episode of Fireside Unsolved. If you haven't already, please like and subscribe to help the channel grow. Until next time, take it easy and be easy, you filthy bastards.